Page 323, I believe, is a blank page in Chapter 4. Is that correct? And we'll take a little bit of notes. We've already seen what happens when we put any function that we already know inside of a square root. Right? As far as special graphs go, any function we know, we can put inside of a square root, and we know what that graph is going to look like. Any function that we know, we now learned what happens if we do the reciprocal of that. We can graph anything the reciprocal of. The last thing we're going to look at is any function that we know, what would happen if you put it in absolute value bars. So far, the only absolute value graphs that we've looked at is in our transformations unit when we did the absolute value of x. And we know that that graph looked like this. Well, what's actually happening with an absolute value graph is because absolute values take negative numbers and make them positive. When you have y equals the absolute value of x, absolute value of f of x, the entire graph will be positive. And what's basically happening with our graph of y equals x is if we graphed y equals x, that's just a straight line with a slope of 1 and a y-intercept of 0. All that's happening is this section over here where the y values were negative, well, the absolute value makes your y values positive, so it just gets flipped over the x-axis, and that's why the graph of y equals the absolute value of x looks like this. But so we've just done lines so far, and we did that with our transformations unit, but now we can do the absolute value of any function. So they could give us a picture and ask us to do the absolute value of it, or they could pick a graph that we already know and do the absolute value. So same kind of idea. We're going to graph our original function first. So 2x plus 3, that's a straight line. Y-intercept of 3. Slope of 1 over 1 up 2. Slope of 2, sorry. Over 1 up 2, or down 1. Down 2 over 1. There's our original function, which is f of x, or f of x, equals 2x plus 3. A key point is going to be our x-intercept. When does that happen? That happens when y is 0. You can plug in 0 for y and solve for x. You're going to get negative 3 over 2 as our x-intercept. That's going to be a key point, because wherever our y values are negative, in other words, this section right here is going to get flipped over our x-axis when we do our absolute value. So when I go to graph our absolute value graph, I'm still going to have negative 3/2 comma 0. This part of my graph, which had our y-intercept of 0, 3, that part of our graph is not going to change, but that dotted red line is going to get flipped up. And we're going to have the graph of it look like this. This first one, since it was like if I write the explicit equation This is the absolute value of f of x, and since f of x was 2x plus 3, this is my explicit equation. And if I think back to transformations, I'll get your question in a second. If I think back to transformations, I could have done this one with transformations. Everything is inside of the absolute value bars. So that 2 is going to be a horizontal compression, and the 3 is going to move it left or right. What do we have to remember when we have a horizontal compression and a horizontal translation? To factor. So this is the same as y equals absolute value. Factor out that 2, and I would have x plus 3 halves. If we did this graph with transformations, transformations would say my parent graph is my absolute value graph. I know points on my parent graph are 0, 0, 1, 1, 2, 2, 3, 3, so on and so forth. What would I have to do with this value? I'd have to multiply my x values by a half. So then I would have 1 half comma 1, 3 halves comma 3. I would still have 0, 0. Then I'm going to have to move it 3 over 2 to the left. Can you see when I move it 3 over 2 to the left, that point matches up? And if I had taken 3 comma 3, first multiply it by 3 halves, and then, multiply it by half, and then moved it 3 over 2 to the left, I would get 0 comma 3. I think graphing the original line and flipping it up is easier in this case than doing our transformations unit. So it's a new tool. Yes, what was your question?
Would we have to plot new points on the, like if we showing the absolute value graph, do we have to plot new points on the new line?
On this new one over here,
Yeah.
you could.
You wouldn't have to.
You wouldn't have to. I mean, you've got a straight line. You're showing that you're reflecting it up. If you wanted to be accurate, right, and you've gone down 2 over 1, down 2 over 1, you're going to have this point here at negative 2. It's not hard as a table of values to get negative 2, negative 1. So I know that I have negative 2, positive 1 now. So again, a table of values is very easy to do. Sometimes you're going to be given a graph and asked to graph the absolute value of it on the same one. So here we're given a cubic graph. It's already been factored, so we know that we have an x-intercept here at negative 3, 1 at 0, and 1 at positive 2. And if I were to graph the absolute value on the same graph, does it make sense that this part's not going to change because my y values are positive? And this part's not going to change because my y values are positive. But these other parts, which I'll sort of dot in red here, that's where my y values are negative. They're going to get flipped up over the x-axis.